On number 17, the directions ask us to make sure I've got it recording. Draw and label diagrams to help solve the related rate problems. So same thing that we were doing, it's just this time they don't even give us pictures to go by. So number 17, the volume of a cube decreases at a rate of 10 meters per or meters cubed per second. So we could say dV dt equals 10 meters, or and because it's decreasing, I'm gonna say negative 10 meters cubed per second. Find the rate at which the side of the cube changes when the side of the cube is 2 meters. Okay, so to be able to do this problem, the first thing that we need to know is how to find the volume of a cube. So let's do a new share. Let's do a whiteboard. So I have basically got a cube. A cube is not going to be pretty, but you know, it's a cube. There we go. So there's my cube. And basically, one side of the cube I'm going to call S. So we know that dV dt equals negative 10 meters cubed per second. So now, how do I find the volume of a cube? So the volume of a cube is actually equal to S cubed. If you don't know that, guys, a quick Google search will help out. A lot of these problems that you're doing on your homework, you may not remember the formulas. Just look up the formulas on Google. Google's a great tool there. All right. So what I'm going to do is I'm going to take the derivative of both sides with respect to time. So I'm going to do ddt of v, and I'm going to do ddt of s cubed. So the derivative of v is going to be 1, and then it's going to be dv dt. So I'm just going to put dv dt. The derivative of s with respect to time is going to be 3s squared ds dt. So it actually turns out on this one I'm solving for ds dt, which makes sense because the problem said find the rate at which the side of the cube changes when the side of the cube is 2 meters. So I really should have made a note here. I'm looking for ds dt when s equals, what's that, 3? 2. When the side of the cube is 2 meters. I get getting my 3's and my 2's all mixed up. Okay. So let's plug in what we know. dV dt is going to be negative 10 equals 3. I know that s is now 2, so I'm going to have 2 squared times ds dt. So we've got negative 10 equals 4 times 3 is 12 ds dt. If I divide both sides by 12, I get negative 10 twelfths, which is equivalent to negative 5 6, and that's going to be meters per second equals ds dt. And that's it. That's that problem worked. How pretty was that one? So sometimes, you know, they look really scary and they actually turn out to be not so bad. And then other times they look really easy and they turn out to be terrible. So it just depends on the problem. Okay, let's do another one on this video. I'm going to do number 19. So same idea. I didn't want to do that, but okay. We're going to do number 19. So same type problem. The radius of a sphere decreases at a rate of 3 meters per second. Find the rate at which the surface area decreases when the radius is 10. So the radius of a sphere, so we could say dr dt, because it's decreasing, it'd be negative 3 meters per second. So that's dr dt. Find the rate at which the surface area. So surface area, a lot of books are going to label as SA. I'm going to label it as S because I don't want to bring the A in. It looks confusing. So I'm going to have a big S for surface area instead of a little s like I used in the previous problem. So I can say that I'm trying to find ds dt when r equals 10. Okay. So let's draw our picture here. So we had our sphere, and my sphere is not going to be pretty. I'm just going to go ahead and warn you. None of my drawings on this computer are pretty. There's my sphere. So let's talk about what we know. Let's start with the formula. So the surface area of a sphere is actually, I'm going to use, like I said, big S, although a lot of things are going to use SA. So big S equals 4 pi r squared. That's the surface area of a sphere. Now, if you don't know that, you can look it up. It's also the derivative of the volume. So I also knew I knew dr dt equals -3 meters per second, and I wanted to find ds dt when r equals, I believe it was, what was r? 10? Okay, so the first thing I'm going to do is take the derivative of the formula we just come up with respect to time. So I'm going to have ddt of big S equals ddt of 4 pi r squared. So when you take the derivative of S, you are going to get 1, and then that's going to be ds dt. I'm just going to write the ds dt. And then the derivative of 4 pi r squared is going to be 8 pi. Remember, pi is just a number. So it's going to be 8 pi r dr dt, because I don't, r is not time. Okay, so we basically got the setup for what I need. Now I'm just going to plug in what I know. So I'm going to change dr dt to be that. I'm going to change r to be that. So I'm going to have ds dt equals 8 pi. R is 10. dr dt is -3. I need to make that big. So when we multiply this out, we are going to get ds dt equals 8 times 10 times -3 is going to be -240 pi meters squared per second, because that's the unit that surface area is meters squared. Okay. Now, that's not the exact answer to this thing. Let me let me go back. So we do get -240 because it is decreasing, but look at what the question asks. So number 19, it asks, find the rate at which the surface area decreases. So what they're telling you is that they know that it's going to be decreasing. So they already know that. So because they tell you it's decreasing, the answer that you will actually plug in is 240 pi meters squared per second. That would be the answer, because they're telling you it is going to be decreasing. So they're basically saying take the negative off and give us that number. The only time you do that is when it says decreases. So if they're already telling you it's decreasing, then you just give them that answer. All right. So I'm going to end the video here. We'll come back. We'll do 2 more problems that are not nice, and we'll go from there.